I'd like to share my story of how I reimagined teaching and learning mathematics. So I tried to think of what kind of story this was going to be. And I was thinking, well, it's not really a fairy tale because there's no magic involved. And it's not a folk tale or a fable because there's no talking animals. And so I think the best way to describe it is overcoming a monster. And so I think that math is often an underdog in a lot of the stories we know. So once upon a time, I was a math teacher starting out, and I loved mathematics, and I thought all my students would love math. And so I was, imagine my surprise when I started working with students from all different grade levels. And not only did they have, dislike mathematics, they actually had a fear of this monster called math. So I knew that, I didn't really understand it, but I knew that if I wanted to be a successful math teacher and I wanted my students to be successful, then I had to figure out why this was the case and help them overcome their fear and become more confident when doing mathematics. So there's all kinds of theories out there as to why students don't like math and don't do well in math. And in fact, if you bring up the topic of math teaching in conversation, sometimes these fierce arguments break out. And actually, in some places, they call it math wars. But what I do know is we need to change the culture and the attitude around mathematics. These are the kind of messages that are out there for our students to see. They're not the kind of messages we want. And if we ask our students if they like mathematics, from our Ontario survey, we can see clearly that the attitudes are changing for students when they go from grade 3 to grade 6 to our non-applied classrooms. So what do people think of when they think about mathematics? Well, back in the 19th century, Bertrand Russell talks about his experience in math classes, and he says, I was learned to memorize that the square of the sum of two numbers is equal to the sum of the square of two numbers increased by twice the product. And so he says, I haven't the vaguest idea of what that means. But when I didn't remember it, a teacher threw a book at my head, and that didn't really increase my intellect at all. And then it reminded me of this poem by Carl Sandburg that says, arithmetic is where the answer is right, and everything is nice. And I look out the window and I see a blue sky, or the answer is wrong, and you have to start all over again and see how it turns out this time. So for most people, math is really about right and wrong answers. It's an exact science. And if you think back to your math classrooms and the math that you did, the math homework, the math questions, the math worksheets, it really was about getting that correct answer. There wasn't a lot of ambiguity. And so if we ask our students what they think about math, a lot of times they'll tell us it's like remembering the rules, memorizing formulas, and the steps that you have to remember to get to an answer. And then students are often seen in classrooms doing questions that look like this. And sometimes we even add in a timer and we say, how many questions can you do before the timer runs out? But you know what? We have technology. So now we're using technology in our classrooms more and more. And so now we see students in front of our classrooms doing questions that look like this. And then we add in a timer, and then we say, how many can you do before the timer runs out or the stars disappear? And so now math isn't just about being correct, it's actually about doing it quickly too. And then we wonder why our students dislike mathematics. Somewhere along the way, teachers started to ask their students to show their work or explain their answer. And what that ended up being is students started giving us solutions that looked like this. So now they're just in neat, tidy rows. And their answers are, again, you're not giving them an opportunity for any independent thinking. It's still really rules evident. And so all we're doing now is we're just taking that correct answer one step further, and we're now asking them to have one correct way of doing their math. I work as a consultant with teachers, and we often look at student work together. And I do find it interesting that my teachers always go to the bottom of the page and look to see if the students got the question right or wrong. And sometimes they mistake a wrong answer for a lack of understanding. I was observing a class where a teacher was posing this question to the students, and it was just 2, 6, and you want to continue the pattern. Clearly, the teacher was looking for 2, 6, 10, 14, 18. which is correct because you're adding 4 each time. A student comes along and gives them 2, 6, 11, 17. And I explained to the teacher that that's still correct because you're adding 4, then 5, and then 6. And really, you can have 2, 6, 2, 6, 2, 6, or 2, 6, 3, 7, 4, 8. So a common mistake when teachers teach patterning is that they expect their students to assume that there's one correct way of completing the pattern. And actually, the only way you can do that is if you give them a rule to start. So if you give them 2 numbers, like 2, 6, or 3 numbers, there's a variety of different answers that are possible and an opportunity for students to defend their answer. Now, regardless of whether the answer is right or wrong, it is really worthwhile for teachers to investigate with their students whether their answers make sense. As well, the probing questions that you ask after you get the answers is where we can consolidate and help with the mathematical understanding. But speaking of questions, what about this one? When am I ever going to use this? This is a question that plagues math teachers in math classes. Well, we could say if you know algebra, then you can figure out how old Mary is if you know that she is 2 years older than twice her age 7 years ago, because I'm sure that's going to come up one time or another. Really, I don't think that students actually want to know how to use their newfound knowledge. I think more likely that they had a misunderstanding. They didn't understand the math that they were learning, and they're just secretly hoping that it's going to be of no use. So, math anxiety seems to occur in students when they're about grade 5 or 6, early adolescent years, and there's a lot of reasons for that. It could be poor math performance. It could be a bad classroom experience. It could be parental influences. But the question I have is, do adults experience math anxiety? Well, let's see. You're ordering a pizza. You know that a pizza with 4 toppings costs $13. A pizza with 7 toppings costs $16.75. I want to know how much it's going to cost for you to buy pizza that's one of those deluxe ones that's 12 toppings. Or maybe you need to figure out how many cans of paint you need to paint a room. And you know that the room has 2 windows and 2 doors, and you know that the can of paint is going to cover 32.5 square meters of wall. Or maybe you're out there shopping and there's all these sales out there and you're trying to figure out how much you're going to save. So if you're uncomfortable with the mathematics, maybe you're starting to feel some of those symptoms of math anxiety. Maybe your heart starts beating more quickly. Maybe you're feeling queasy. And then you start looking around desperately for help and you're thinking, where's my calculator? And then you think, I have an app for that, I'm sure. Or maybe even better yet, I'm going to give it to that guy over there to do because he has the math gene. And actually, you know that doesn't really exist, right? So some math experts believe that math anxiety exists because when you started doing math and you weren't good at it, you just avoided doing any more math for the rest of your life. So you didn't take any more math-related courses in high school or in post-secondary studies. But we know that primary students are confident and are highly capable of doing the mathematics, and they don't show much signs of anxiety. So what I think happens is when students are into junior and intermediate grades, they start to feel the anxieties of doing math, and that's because they're so worried about getting those right answers. And those worries in their head actually divert their brain power and working memory away from the math itself. So much so that the lack of self-esteem and lack of confidence actually doesn't allow their brain to function properly. So we know that the working memory is housed in the prefrontal cortex of the brain. We know that on the left side is responsible for the verbal tasks, the right, the spatial. And we know that when students are in pressure-filled situations, what happens is their verbal brain power goes into overdrive, and it becomes more difficult for them to access those verbal resources, which is sometimes why we see students struggle with math word problems. We also know that children that have math anxiety show an increased activity in the fear center, but it's actually accompanied by a decrease in the numerical information processing regions of the brain. So a student who is math anxious actually will have difficulty reasoning through a math problem. So what do teachers do when students exhibit these signs of math anxiety or struggling with math? Well, we want to help them, and so we're going to intensify what they don't know, and we're going to make them do it over and over and over again. Or we're going to break it down into these little small steps and hope it helps them. Or better yet, math is just boring. We're going to make it more interesting, and we're going to put into these real-life contexts and make it relevant for them, no matter how contrived that is. But remember, a math problem is still a math problem, even if it's about baseball. So when I started teaching, a friend of mine gave me a book, and it was called. And in this book, there's a boy named Ramon. And Ramon loved to draw. But he had a brother that was mean and told him that his pictures weren't very accurate. And so he became discouraged and he stopped drawing. Now his sister came along and she put the pictures up on the wall and she said, you know what, I like them because that vase is vase-ish. And so he has this new way of looking at his drawings, he restores his confidence, and he becomes he starts to draw again. So I began to wonder if maybe we should be teaching math more math-ishly. So I'm going to share with you some strategies which allows teachers to meet the needs of most of their students in their classrooms at the same time. And it really is about giving them a good question and a good task. And this task has to be inclusive, so it means that different students in the classroom can use different strategies and different ways to approach the problem. It also means that it's inclusive and it's accessible to all students. So that means that students that are at different stages of development will be able to benefit and grow from doing that task. What that means now is that students in that classroom will be part of the learning conversation. It also means that they will be valued and important members of that learning community, which means they're going to gain confidence, they're going to persevere with their math tasks, and we're going to see improvement in our students. So let's take a look at this question here. So this is a question that might have been given to students that are doing a class in fractions. But what if I'd said this? What if I said, choose any two fractions you want with different denominators, and that their sum is going to be just a little bit more than 1. Tell me what that sum is, and explain to me how you did it. So notice there's no numbers here. Students can choose whatever fractions they're comfortable with to do this problem. What if instead of saying, take the formula and use the formula and tell me the area of a circle? So what if instead of I said, one of the measurements of a circle is 6 units. Tell me something about at least one other measurement of the circle. What if I give them a graph that looks like this and said, tell me a story about this bar graph? Imagine the possibilities. Or what if I just started with the answer, and the answer was 5? What could the question have been? Well, some students might tell me it's 1, 2, 3, 4, 5 fingers on my hand. Some of them will be thinking about operations, so they're going to tell me 3 plus 2 or 5 take away 0. Maybe they're thinking of that skill testing question and give you something like this. Or what most of you are probably thinking, what is the atomic number of boron? What is the number of platonic solids? The point here is that a number 5 or any number can be represented in many different ways, but the way you represent that number tells you something about the number, like 5 follows 1, 2, 3, 4 when you're counting. In algebra, we always ask students to solve for x. But what if I said, give them 4 equations and to ask them which 2 of these 4 relationships are most alike and why? And maybe they're just going to tell me that it's these 2 because we see a y, an x, and a 4 and a 3. Maybe they'll make a table of values. Maybe they'll look at the graph. The big idea here is that when you compare mathematical relationships, groups of relationships will behave in similar ways. We know that visual representations are vital in teaching and learning mathematics. And children from a very young age make sense of the world by looking at picture books. So why can't we show a picture to students and help them make sense of the math they're learning? Here's a picture that shows the operation of multiplication is the total count of equal groups. But it also shows them that if you take apart groups and put them back together, it helps them calculate more effectively. There's a picture that helps students talk and have conversations around fractions and fair sharing. What are the benefits of questions like this? Math is no longer black and white anymore, and it's not about the kids in the class who get it and those who don't. And more students are likely to try these questions and not shut down. We're now turning those passive, struggling learners into active learners in their classroom. And more like other subjects, we're allowing students to express their own point of view, have their own interpretations, and be able to share their solutions. These approaches allow teachers to set up what we call a math talk learning community, which we know is really important for students to understand math concepts. These examples also allow teachers to create an environment where one another's ideas. And it's no longer just about recalling facts, but they're actually responding to open and rich questions. We have teachers out there who are doing these, who are working with these strategies, and the students in the classroom tell us that they understand the math better, they're more confident, it makes more sense to them. That math is better when you can visualize it than trying to picture numbers in your head, and that math is easier and more fun. And we also know that students from these classrooms are showing increases in student achievement. So we can't just end this story by saying that we want students to like mathematics, be more confident, or persevere with problem solving. And we can't be satisfied with graduating a generation of high school students that are quantitatively literate. We want our students to be outstanding in mathematics. We want them to be our future innovators in science, technology, engineering, and mathematics. So what good is it for people to walk around with vague memories of geometric figures and formulas in their head and clear memories of how they hated it or how they were afraid of it? Wouldn't it be better if people remembered their math classes as being inspiring, where they were able to be creative and critical thinkers? And there's likely a number of different factors, a combination of factors really, that determine the success of a student in math today, including their parents, their teachers, their peers, and their own attitudes towards learning. But what we can do is we can make a great start by first of all changing the culture around mathematics so that being bad at math is unacceptable. We also want to provide our students with opportunities to answer questions that pique their curiosities, that are accessible to all of them, and that allow them to think about the mathematics and talk about the mathematics. If we want more innovation in our classrooms and less math anxieties in our students, we need to move beyond the idea that we only focus on optimizing what we know is the right answer. Rather,